Hello, future pharmacists. Welcome to my YouTube channel, GPAT. Today, we are going to talk about alkaloids from pharmacognosy subject. These are the other topics I'm going to talk about later. Next. So, first we are going to talk about alkaloids. Alkaloids are organic compounds that are produced by plants and other materials. They are typically consisting of nitrogen in a heterocyclic ring. Sometimes they have oxygen and sulfur as well. There are many alkaloids that are known for their physiological effects, including medicinal properties, though they have toxicity or psychoactive effects as well. For example, morphine, nicotine, caffeine, etc. The first isolated alkaloid was morphine from opium in 1804. It was by Professor Sir Turner, and the alkaloid's name was proposed by Missner in 1819. Actually, Missner was a German pharmacist. He said that alkaloid means alkaline-like substance. The first synthesized alkaloid was quinine. We are going to talk about different properties of alkaloids and their deviations. First, most alkaloids consist of oxygen in their structure and are colorless crystals. There are some exceptions like oxygen-free alkaloids, which are nicotine or quinine. These are typically volatile, colorless, oily liquids. We did study that alkaloids are crystals, but it means only some alkaloids. Like we said, most of the alkaloids are crystalline, but there are some alkaloids which are oily liquids. Example, nicotine and quinine. These both are typically volatile and colorless. Okay, we are seeing here that most alkaloids are colorless, but there are some alkaloids with consist colors. Example, berberine in yellow color, betadine in red color, sanguinarine in copper red color. Next, most alkaloids are weak bases. We do know the alkaloid consists of nitrogen, which is a basic compound. So it makes most of the alkaloids which contain nitrogen as weak bases. There are some exceptions like theobromine and theophylline. These are amphoteric substances, which means that they can act both as acid and base. Alkaloids consist of sharp melting point. They are easily are decomposed by heat. They have bitter flavor. Most alkaloids are fully water soluble. We have to remember this point. They are readily soluble. They are readily soluble in polar organic solvent. There are exceptions, which is caffeine, ephedrine, and pilocarpine. So we do know that caffeine can be dissolved in boiling water. Next, alkaloidal salts. So alkaloidal salts are compounds formed when alkaloids react with acids. These salts are often more water soluble than corresponding alkaloids. These actually are easy to handle and administer. That is why we take alkaloidal salts for extraction process rather than alkaloids directly sometimes. So they are water soluble. We do know that alkaloids are not water soluble. Alkaloids are actually soluble in polar organic solvent. Alkaloidal salts are poorly soluble in organic solvent, and alkaloidal salts are soluble in alcohol as well. So there is an exception for alkaloidal salts as well. Example, scopolamine hydrobromide, which is soluble in organic solvent. We do have to remember alkaloids are not soluble in water. Alkaloidal salts are soluble in water. Alkaloidal salts are poorly soluble in organic solvent. Alkaloids are soluble in organic solvent. Next, some alkaloids are optically active. So optically active means nothing but it can rotate the plane of a polarized light. It can rotate plane of polarized light. This property is due to presence of chiral centers in molecule. So when an atom with four different groups attached to them is called chiral center. Chiral molecules exist as two non-superimposable mirror images of each other. This is known as enantiomers. So enantiomers are of two types, levorotatory and extrarotatory. Levorotatory means the rotation of the plane of the polarized light is towards the counter clockwise. Like this is the clockwise, levorotatory goes in opposite direction and dextrorotatory means towards the clockwise direction. So quinine is levorotatory, conine is dextrorotatory. Next, we know some alkaloids are optically active, so some should be optically inactive. Example, papaverine. Next, we are going to talk about the isolation and extraction process. So first of all, isolation process, which is mainly done by Stasotto method. We are going to discuss it in further video. And for now, this is a normal apparatus and let us see about this Stasotto method and etc. Okay, we take the picture here and we are going to learn about the processes. So oxide extraction method. This is a normal method. We use organic solvents to extract alkaloids. Remember, alkaloids are soluble in organic polar organic solvents. This is from a powdered plant material. Next is Stas Otto method. So Stas Otto method is nothing but modified version of Soxhlet apparatus. So what happens is in this picture we take the sample in this area, sample extract in this area. Then due to the heat, it travels from here to here and it consists of a condenser. After it cools down, it mixes in this thimble area and then it is again going down like this via this tube and mixing with the sap. So this is what happens in this Strasotto method. Next, here, oh, by the way, in Strasotto method, we are treating plant material with acidified ethanol and extracting with petroleum ether. We add petroleum ether because we want to remove the fats, which we do not want actually. And finally, extraction of alkaloids is done with alcohol. And for doing this, we use aqueous residue. So, what this actually means, when we do this process, we actually get two solutions. One is aqueous, one is organic, one is aqueous layer. So, we take the aqueous layer and we do this process. We feel after we get the aqueous layer, we are going to add alcohol to extract them properly. Next, Kippenberger's process we just have to know there are three existing processes over here. That is first Soxhlet apparatus, next Stas Otto process, next Kepler's Burgers process. So this is extraction. This is extraction method. In we isolated it properly using these three, but how do we extract? So we take the mixture of bases. Bases are free bases, nothing but alkaloids, and they are separated using various methods. Chromatography, thin air chromatography, steam distillation. Especially steam distillation is mainly used for volatile liquid alkaloids. Example, conine, nicotine, and spartan. We have to remember these properties as well. Next, okay, let us talk about different types of alkaloids. True alkaloids, protoalkaloids, and pseudoalkaloids. So, true alkaloids are derived from amine group. Protoalkaloids are also called as amino alkaloids. That means they are also derived from amine group. Pseudoalkaloids, in the name we can identify, they are not derived from amine group. So, nitrogen is present inside this ring, heterocyclic ring. That is why they are called true alkaloids because they are amine derived and nitrogen is inside the ring. Protoalkaloids are amino alkaloids that derived from amine, but the nitrogen is not on the hetero ring. That is why, like it can be on the side chain. Next, pseudoalkaloids. So nitrogen is inside the ring. Like it has functions like alkaloid, but it is not from amine derivation. Like it is half. That is why alkaloid and half not so alkaloid like property. That is why it is called a pseudoalkaloid. Now, true alkaloid example: nicotine, atropine, morphine. Protoalkaloids or amino alkaloids example mescaline, ephedrine, and colchicine. Next, pseudoalkaloids, caffeine, because there are some different properties related to this. Theobromine, theophylline, and steroidal alkaloids. We are going to discuss about the steroidal alkaloids. We are going to discuss about steroidal alkaloids example in classification. Next, chemical tests. These are general chemical tests we perform on alkaloids to determine if they are alkaloids or not. First one, Mayer's. In Mayer's test, we take the sample and add potassium mercury chloride to give the cream color in PPT. In Dragendorf's test, we're going to take the sample, add potassium bismuth chloride. We are going to get brick red color. Then in Hagner's test, we're going to add potassium iodide in for the sample to get the yellow color. Next, in Wagner's process, we add picric acid to get brick red color. So what we are remembering is in Mayer's process, it is cream color. In Dragendorf's process, it is brick red color. In Hagner, it is yellow. And in Wagner's, brick red color again. Classification. There are four types of classification: chemical, biosynthetic, pharmacological, taxonomic. So, chemical classification is based on heterocyclic nucleus. Like, does it contain indole or phenolene, etc. Like that type of classification, chemical classification. Biosynthetic is precursor based. Precursor means we get a substance because of other substance. So this is the substance we called as precursor. Pharmacological. In pharmacological, we divide them based on physiological responses like anti-inflammatory, anti-malarial, etc. Like that. Next, taxonomic, family based or genus based. So I'm going to discuss classification in further classes. Thank you for watching my video. Stay tuned.